wait until the last guests have entered the room. Good afternoon, everybody. Welcome to our session on integrating of statistical and geospatial information using Inspire standards. I'm really impressed. The room is full again. Thank you. We are running this session already a couple of years over the last Inspire conferences because we think it's important that we connect our statistical community with our GS community. And we as well, in my position from Eurostat, we see really interesting results coming up in the member states implementation. And as well, we think outside the statistical community, the GIS community needs to be informed what's going on there as well. So, welcome to the session. I put it again under this nice citation from Lars Henrik Barker. Vision without action is a daydream. Action without vision is a nightmare. Yeah, you like it? Yeah, okay. No, I think it's really important. Just for the beginning of the session, I just want to mention we have put some leaflets out there for the EFGS conference, and Lars Henrik Barker is one of the grandfathers of that conference. If you want to attend, later on at the end of the session, the current president of the EFGS will invite you again to this conference and say a couple of words. With that one, I invite our first speaker to the floor. We hear about Inspire Harmonization Experiences by Statistics Netherlands, and we will hear what kind of issues they actually have observed by moving it into production, and what is their proceeded way forward. Peter, please, the floor is yours.
Thank you.
Sorry.
There's no mouse.
No, there's no mouse. There's a mouse.
Yeah, Yep, thank you.
For the session, you have maximum 15-minute time, 15 minutes to speak.
Okay, so that's 14:18.
Yes, I will break you at 14 minutes. Yes.
Welcome to my presentation on our experiences at Statistics Netherlands for harmonizing Inspire data. My name is Peter Bresters. I work at Statistical Netherlands for 9 years now, and I'm responsible for implementing Inspire. Let me first tell you short how Inspire is organized in the Netherlands. We have an organization called GeoNovum who coordinates everything. And one of the things they did was try to point out which organizations are responsible for which themes. And here you see the list of themes that Statistics Netherlands is regarded responsible for. So, of course, statistical units, population distribution, but also human health statistics and land use. And in this presentation, I will tell some of our experiences on these themes. So what is harmonization about? Well, actually it's just fitting the data we have into the Inspire data models. And those models look like this. Don't try to understand it, but this is what it has to go into. And how did we do that? Well, basically we designed the transformations from the as-is data into the Inspire data model within the program HAIL, Humble Alignment Editor from WeTransform. And then we had two different approaches for different themes. The statistical factor units and the land use data, those will be harmonized by our hosting organization, PDOK. This does not mean that they will do it on their own. They do it with my help, because I am the domain expert, so I will tell them what goes into what. But finally, the transformation is done within their database environment and presented finally as geoservices harmonized the way Inspire likes. The advantage of this way is that we can continue delivering our as-is data to them, and they can serve two services, one as-is, like the Dutch users are used to, and one conform Inspire, basically meant for the rest of Europe. Another approach we took for the statistical unit grids. There we did the harmonization ourselves, so we created GML files harmonized with a HIL, and we will deliver them to our hosting organization. So it's a different approach, but that's mainly because there is no as-is statistical unit grid. The HIL transformation looks like this. It has passed many slides this Congress. I've seen it a lot, but basically on the left side you have your as-is data, and in this case it was a shapefile. You can import it, and it recognizes a data model, and it shows it on the left side. And the number of features is numbered behind it. And in the middle you see the target data model. That is important from the Inspire web service, where you can import all the data models. And then what you do is just point out which thing goes into what. So that's on the right side. So how did we plan to do this? First, we started with the vector statistical units. We started actually in 2050, and we just finished. Well, we stopped the way it is now, but there is a web service, and you can approach it. And at the moment we are working on the grid cells, and that is within a Geostat project, where we are trying to create the grid cells for the census of 2021. I'll come to that later. Secondly, we will do a land use in 2018, so we haven't dived into that yet. And finally, if considered useful, we will do a population distribution and human health. And here you already see some hesitation from my side, and I will come to that back later. So first, is vector statistical units. We have as-is data sets with 23 years times 20 types of units, and that makes 460 layers. And unfortunately, we have a model that cannot distinguish in types. So we have to put all those 460 layers all together in one layer, and that's not very useful for the user, because how does he get it out again? Well, one thing that we used is actually misused the tessellation field, and we put in the type there, but it was not meant for that, but it was the only way we could think of to distinguish between the separate layers. And then you can distinguish them again with stored queries. We haven't defined them yet, but that's the way a user could be helped to get them out again. But it would have been much more easier if we could use group layers. But unfortunately, the software our hosting organization is using, GeoServer, is not dealing that well with group layers, because you can't define a default layer within GeoServer for a group layer, and also keys cannot be defined for group layers, and then you get validation errors. So either this has to be solved on the side of GeoServer, or the validators must be less strict. Well, the result of this vector statistical unit harmonization web service can be found with the URL below. And this is the data model for vector statistical units. So on the right bottom side you see the statistical tessellation that we misused for the type. Then the statistical grid. This one we are testing within the statistical no, I always struggle with this acronym. The statistical geospatial framework. And we are testing if we can use the grids, the 1 kilometer grids for the census of 2021. And we can't use the as-is grids because they are in a local projection. So if you start to put them in the Lambert equal area, which Inspire asks us to use, then you'll get very odd squares like this. So we just have to redefine them, and and we were lucky they were already defined on the EFGS website. So that's where we downloaded them all. Then we got shape files, but they are not yet in fully in the Inspire data model. So that we did with Hale, and we did it for 7 of the participating countries in the Geostat 3 project. And by the end of this year, we hope to have a web service hosting those grids. And then they will look like this. So I put also one of the Dutch isles in there, just for testing purposes. It's always good to have a small one for testing. And this, so you see 2 attributes. It's really a very simple data set. Okay, then we come to population distribution and human health. I see a desperate cluster leader. We have a problem with this data model because there is no geometry in it. And then, well, you can create GML files, but it doesn't make sense. It gives you one record with all the values in it, and nobody can use that. So finally, I thought, why are we actually trying to reharmonize this data? Why don't we just stick to the STMX files as we already delivered to Eurostat? Because those data sets have already been harmonized, both semantically and technically. They are machine readable at the following URL. And it would save all the European statistical offices a lot of effort if we could just use them and not start to reharmonize all this data into another data model where nobody asked for. So then I would say let's just stick to the STMX, and we can only use, there's only one situation where we could use the new data model. That is when there are new population distribution teams, like the one for the census of 2001, because that is a new one. And that is exactly what Eurostat did. They defined a new STMX format for this census, and that is good. But I think it's also good to stick to the encoding of STMX, because that is what we are used to in the statistical world. Well, that's my opinion about population distribution and human health. If we then all stick to STMX, there is still a problem for the GIS users, because they can't make maps from STMX. And then we need a tool that combines those STMX files or other tables at your office with the geoservices that are Inspire harmonized, the statistical units. And if you combine those, a GIS user is normally doing that, but you could also do that online with a machine or a service, and in this case a table joining service. And that would create a thematical map, again an online map as a geoservice. And so that's what we are proposing as a solution for this. And we have a few motivations for it to do this. In this way, data remains at the source, so no unnecessary copies of data. The actuality of the data is higher because once a table is updated, you can immediately update the online maps. And that is not the case when we start to predefine all the maps. And then you will have not non-updated geoservices once the tables are updated. The tables at Statistical Office for the Statistical Office of the Netherlands are, for instance, updated 4 times a year, but our geoservices are only updated once a year, just because it's too expensive to do it 4 times a year. Another thing is there is a too large amount of tables to make maps from in advance. We have 400 tables with, again, 50 attributes, and if you would have to make maps of all these themes, it would just be too costly. So we say, why not let the user make all these maps on demand? It's much more cheaper, and it precauses us from making maps that are not wanted. The solution of the table joining service is based on Inspire standards. So both the geoservices are from Statistical Units, and the tables can be from SDMX. And the outcome, well, that is not within an Inspire theme. But again, Inspire doesn't ask us to make those combined themes. It's only needed for the users. So we don't have to have an Inspire standard for that. And finally, I think this is the way to make the statistical data available for GIS users. And if they make friendly applications that use the table joining service, it will become available for everybody. So I come to my conclusions. The statistical unit factor needs an attribute, or group layers should be possible. One of the ways should be needed. Otherwise, we can't create useful geoservices. Secondly, I think we should continue using the SDMX services for population distribution and human health, and not start to re-harmonize them again. And finally, I think we need tools like a table joining service to join PD and HH themes with statistical units to make Inspire useful for geo-minded statistical users like we all are. Thank you for your attention.
Peter, I apologize. The sounds were not from my cell phone taking you. Your time is up. Okay. You still have a couple of minutes for questions. We have the floor is open for 1 or 2 questions. We have a hostess with a microphone. Please wait until she arrives at your place. Thank you.
Nathalie Delattre from Belgium. So you raised similar conclusion than my previous presentation yesterday. But I have a question because I would like to know how we can transfer this message to the MIG-T, because we are some member of the MIG-T, and see, I don't know if the thematic, yes. So the question is how we could try to promote or to tell the issues that you have, and how we could transfer the communication so that it can be fruitful.
Thank you very much, Nathalie.
Maybe I can answer that.
There's also Hugo in the room who just go ahead, Mirolas.
Yeah. Okay, I would just like to say that right after the session at 3:30 there will be an Inspire Statistical Cluster meeting. We meet at the Inspire booth, and the harmonization of the PD team will be the main topic that we plan to address in this meeting. So you're very welcome. Come to the Inspire booth after the session.
Hugo, you want to intervene as well? Okay. Just quick. While the microphone is moving to Hugo, I have just one question or one remark there. You might want to need to discuss also questions on availability and reliability of the services, because if we implement a table join service, some of the services need to be created on the fly and might not be there in 3 milliseconds. But I mean, this is another topic, technical discussion.
Thank you. Thank you, Hannes. Well, I have a very simplistic view on this. We've had some more complex discussions with the colleague in Eurostat on this issue. But I fully support his approach. And actually, it was already in the beginning, when the experts came together, that we said we are going to use always the interoperabilities which are already established within the different communities. And we have SDMX, we also have the JTAG format with the joint table services. So this is definitely the way to go. But the question that I have, of course, and I'm sure we can change these type of guidance in the model, etc. It's just a matter of common sense to do so. So for that reason, I see the colleague nodding there. I'm sure they will come to an operational agreement very soon. But my question relates actually to the underlying surveys of the statistical data. We have in Europe, every country does this area frame sampling surveys. In France, it's called TERUTI. We have a European thing which is called Lucas. And of course, the actual survey data itself, which then later on is turned into statistics, in C is also what we could compare sensor data. It's been observed somewhere and then aggregated through statistical processes to the level of a statistical unit or an administrative unit. Now, the survey data itself can also be used in some cases for other purposes. I'm thinking of the Copernicus, or aggregated through different calculations to other scales, spatial objects. What is your opinion from the statistical services to actually work with the underlying survey data and produce products which are also of use to other use cases?
Okay.
A short answer, please.
Well,
the question was already too long.
Yes, the question was already too long and we are already overrunning. So that's the reason I'm saying
one important issue there is privacy, because if you want to have the underlying data, it's mostly the microdata, and that is always an issue. You can't just publish that. So I don't know if that's really an answer to your question, but it's...
Okay.
Okay.
Thank you very much. Thank you very much all for your questions, for your attendance. We come to the next speaker, Pier Giorgio Zacchedo from the Federal Agency of Cartography and Geodesy in Germany, will update us on the territorial dimension and SDG indicators, the contribution of geospatial data analysis in combination with statistical data.
Very long title.
Yes.
Okay.
So please, the floor is yours.
Good afternoon. I realize that I'm the only speaker from the geospatial community in this session. That's good. I'm well embraced by the statistical community, and I'm always inspired working with the statistical community on a global and on a European level, and also on the national level. However, this might indicate somehow that this topic, integration of statistics and geospatial data, is mainly driven by the statistical community at this moment. Okay. However, my presentation is about how geospatial data and its combination with statistical data can contribute to the SDG monitoring. So the Sustainable Development Goals. And this presentation has been prepared together. I prepared this together with Francisco Vala from Portugal, also coming from the statistical office in Portugal. What have been the main drivers for this working group since its establishment? You can say that on the one hand, the Sustainable Development Goals, its framework and the indicator creation, as well as the Statistical Geospatial framework, which was also addressed by Peter beforehand. These are the main drivers, and the working group was established in 2014. The working group on data integration from GGIM Europe, and my presentation will tackle and will explain to you what has happened in this period 2014 until today, and also what will happen in the upcoming month. What has happened so far? We have produced several reports on certain topics, and the first report, which was well received, at least in the GGIM Europe community, was on the priority user needs for combinations of data. And this report provides you with more than 40 use cases where statistical data and geospatial data were combined and provided benefits for the community or for the national spatial data infrastructure. And these use cases were also linked to the Sustainable Development Goals as well as to the European flagship initiatives, to the European directives and so on. So that was the first report. And then from 2015 to 2017, 3 other reports were created, one on interoperability frameworks, and here also a brief description on what is Inspire about, what is Copernicus about, but also what is the Statistical Geospatial Framework about is mentioned in the one report. There's another report on side effects after data combination, so which obstacles you encounter after data combination. And the last report was on methods and interactions. And this is what we are talking about, integration of statistical and geospatial data. And this report provides you of 5 country perspectives, how national institutional arrangements or how national institutional arrangements are in place in several countries. They are different. Sometimes you have a law. Both Geospatial Agency and Statistical Office are relying on. Sometimes you have a memorandum of understanding, like in Portugal or in Germany. And this works, and the cooperation works, and the methods are also explained in this report, and they are also linked to the main initiatives in Europe, the Sustainable Development Goals monitoring, Statistical Geospatial Framework, and as one example also the Geostat projects supported by Eurostat. Okay, you can find all these reports on the website. They are uploaded and you can download it if you are interested in. That was the first part of the presentation, so what we have done so far. The second part of the presentation is what we are going to do now. The plenary, GGIM Europe has a plenary session once a year. The vice chair from the executive committee is here, Antonio, from Spain. And the plenary last year provided us with 2 tasks mainly. The first task is a supportive task that we contribute to the global initiative on creating this geospatial lens on the Sustainable Development Indicator Framework. And this process is mainly driven by a so-called interagency and expert group on the Sustainable Development Goals, and they have established a working group on geospatial information. And we, as a European regional committee, shall contribute to this process. And the second task is specifically on this working group to provide practical examples, best practice examples on national implementations, and also to continue to strengthen the links between the communities, and not only with the statistical community, that I think is improving and works very well, but also with other communities as well. This is just a slide for the organizational framework. So you have on top the high-level interagency expert group where no geospatial representative is a member of. It's mainly driven by the statistical offices in the countries, and they have identified that this geospatial component for the SDG framework is important, and so they have established a working group on geospatial or geographic information, and the European group shall contribute to that. The first action of this group has been to discuss and also publish a so-called shortlist on geospatial indicators. That means indicators for which geospatial information has a direct contribution. And you see here a list of 15 indicators from Tier 1, Tier 2, Tier 3. I don't know if you are aware of this, but I think so. Classification, that means Tier 1, you have the method and the data. Tier 2 means you have the method, but not the data available so far. And for Tier 3, there are no methods and no data available so far. So these 15 indicators, there have been 3 have been chosen from this group and have been further elaborated, the methods, and this global group also tackled some cross-cutting issues on disaggregation, on the question alternative data sources, what alternative data sources are available, and also the question national versus global data to be used to monitor the indicators. And in Europe, we have taken this process, this global process, to discuss what can this working group in Europe contribute to this initiative. And we have started the discussion to think about, well, the indicators should be discussed on, for a global perspective and also for a regional perspective for Europe, but also the local, the national perspective should be taken into account. And so we discussed also national sustainable strategies. There are some in place in Germany, Sweden, Switzerland, and so on. We discussed also contributions by the European Commission from the Joint Research Center. They made an evaluation on the INSPIRE data sets and themes contributing to the SDGs and also to the European indicators as well. GEO is another, the Global Earth Observation Group is another platform where they discuss the SDGs and also the contribution of Earth observation for the SDGs and so on. Then Eurostat published a report on European indicators. So the national indicators differ from the global ones, and also the European indicators differ from the global ones and from the national ones. So we have a 3-level set of indicators at the moment. And then you have platforms. This is only one example, the Atlas of the Human Planet, I think provided by the Joint Research Center as well, where you can use data and test data and use it for the indicator monitoring. And all this information was considered, and then the plenary this year assigned to the working group 2 tasks. The first task is about the current deliverables available. I mentioned that in my first part of the presentation. And to use these recommendations in these 4 reports and to draft an outreach paper on data integration topics. So that is the first task, and the second task is to select 1 or 3 global indicators and compare it for the global level, regional level, and also for the national level. And to ask the question, how can INSPIRE contribute to that? How can Copernicus contribute to that for the European perspective? Concerning the second task, I will not go in detail to the first task. Concerning to the second task, there is already a scoping paper available. These addresses the main issues we are trying to tackle in the upcoming month. We have we will try to reflect the experiences in Europe and also on the national level, and also the activities of this global high-level working group on geospatial information on the indicators. There has been a request to the geospatial agencies and to the statistical agencies in Europe to look at some indicators and look at the metadata. It's not metadata in INSPIRE sense. It's a description of the indicator, of the method, and of the data availability. Some European agencies were asked to look at the EU SDG indicators, and also countries were asked to compare these global indicators with national indicators and to check and assess the methodology as well as the data availability. And the current status is that this is a first list. I will not go into detail to these indicators, but these are from the short list, 15 indicators, you remember. These are indicators taken from the short list, and you see that on the right-hand side, some national mapping agencies as well as statistical offices have volunteered to check the methodology and check the data availability in the upcoming month, and to compile this into one report. And the European Commission was asked also to do the same exercise for the European indicators, for the indicators published by the European Commission and compare this or bring this into the same perspective. So how can we monitor poverty with a different set of indicators, and what is the difference and why? Okay, the phase we are in at the moment is phase 2. Phase 1 you see is accomplished. Phase 2 is that we are in the process to select specific indicators for which the integration is needed and which are relevant for the SDG monitoring. This will be done by the end of the year, and then we will discuss in the working group also how to compare one indicator for the global level, for the regional level, and also for the national level, because the data might be different and also the method might be different to monitor poverty. For example, in Germany, it's different than on a global level. This is only one example. And phase 4 will comprise best practices. We hope to provide then best practices with the experience of the strong interaction between the statistical community and the geospatial community. That is the current status, and I thank you very much for your attention.
Thank you very much, Pier Giorgio. Really interesting presentation. The floor is open for questions. No one has a question. Everything is settled.
only statisticians here, you know, because there's
if I look
it's clear to them.
No, if I look in the room, then I think we have a well-mixed tendency here. For me, the interesting question was in your presentation to learn about the usage of the word tier 1, 2, and 3 with data and models not existing and sometimes existing for data or sometimes existing for model. How do you solve that in the future to get all these models or the data up and running? What are you planning for that one?
Well, I can't provide a comprehensive answer, but yeah. This working group on geospatial information on this interagency expert group level, that is the group where we identify indicators which are from tier 2, for example, where the methodology seemed to be clear, but the data is not available. That's tier 2. Yeah. And there are custodian agencies on the UN level who are trying to identify how can we monitor this indicator with which data, and we are trying to contribute to that. And if that is clear, then the tier 2 indicator will be shifted to tier 1. Okay. And the same applies for tier 3. So where the methodology is not clear at the moment and the data is not available. And so we try to interact with custodian agencies from the UN level, with national agencies contributing to that process to analyze that and to understand what is the indicator about. That's not always easy. Yeah. Okay. And as I said, you have a 3 set of indicators now. You have the national ones, you have the regional ones, and you have the global ones. Okay. And as a country, you have to fulfill all 3 levels. That's clear because UN addresses the member state and not a custodian agency.
Okay, thank you very much for that answer. There's one more question.
One question, do you have a timetable or a priority list? So that we look on Inspire, we have a timetable and we have priorities, so Annex 1, 2, and 3. Is there anything you want to put pressure in? You say this is our priority? Well, the priority is set by the short list. You have an indicator set on a global level with 231 indicators. And they are all relevant, and they have a timetable until you have to reach this goal until 2020 or 2030 or 2015. No, 2015 is over. But 2020, 2025, and 2030. And that is the timetable. And we have selected 15 indicators now as a preliminary shortlist, and we will focus on these.
Thank you very much, Pier Giorgio.
Thanks.
We get the next presentation. We are moving from Germany to the south to Slovenia, and I invite colleague, Moka, to the stage. Mozza, sorry. Pronunciation is not the best. Show us, being the Eurostat project manager in the grant, they are always in the forefront of data visualization in one of the statistical offices together with our Finnish colleagues. So I'm looking forward to see what you have accomplished in the last year. Thank you.
Thank you. Good afternoon. My name is Mojca Merc and I come from Statistics Slovenia. Well, my presentation won't be focused so much on the INSPIRE standard because we are still looking for some solutions, at least on the metadata field. But I will be talking about activities that will help us to upgrade our integrated system for production and dissemination of geospatial statistical data. This system namely provides a service of free and open geospatial statistics, which can be easily accessible by a web GIS application named Stage. And Stage actually is a core part of the integrated system, and it was developed within one of the previous frameworks of the Eurostat grant merging statistics and geospatial information. Well, the work on the current grant action is organized in 4 work packages, and it's performed by 3 institutions. One is Statistical Office, the other 2 are National Institute for Public Health, who is the authorized producer on health statistics, and the Geodetic Institute, who is the developer of Stage software, and they are also helping us with INSPIRE standards. As you can see from the list, the work is not focused only on the upgrade of Stage application, but also we have also planned activities to establish new geospatial infrastructure, statistical infrastructure in form of 2 databases, one on income statistics, the other on health statistics. And there are also some activities planned to cover the statistical confidentiality issues and development of new indicators. I will continue my presentation with giving you explanation on each working package, and I'll start with the work that was carried out by the National Institute of Public Health. Well, the situation on data availability on health issues was used to be, at least for the territorial levels below NUTS regions, quite low. So the National Institute decided to establish a database. They linked different sources kept by the Institute with the other institutions, with data from other institutions. So they got now the database that enables them to produce on the annual basis about 30 health indicators. And now more detailed information are available on the health status and population, about risk factors, prevention, causes of death. That since these data are available on the LAU2 local administrative units. The colleagues also did some work on the downscaling method, since they wanted to provide data on certain themes that are collected by the European Health Survey. These indicators were provided by the Poisson regression model, and it also they needed to apply also some other statistical and administrative data sources to be able to prepare this estimation on the local administrative level. Well, unfortunately, this data hasn't been uploaded in the stage application yet, but I can show you on this map how this will look like, for example, later when data will be uploaded. Well, the story on income statistic was quite similar as with health statistics. Also, data sources were scattered among different institutions, and they were kept in different formats. So now this all is linked together in a quite big database. It contains more than 400 variables, and now actually all the income data is available on one place. But since these activities are still ongoing, it's impossible to predict at the moment which new aid indicators will be available on which territorial level. But for sure, we will be able to provide some income structure indicators and data for poverty. This is namely related to the confidentiality issues, since income data is quite sensitive. And actually, we can say that the current method that is used for data protection, self-suppression method, it's not really appropriate to use in this with this kind of data. So new methods are being examined. One is record swapping. This method actually identifies high-risk records, and this is done by some criteria that is set, and then after that the algorithm looks for similar records from a different geographical area, and when the matches are found, the IDs of geolocation are switched between them. The SQL key method is the other method that is actually a perturbation method, and it adjusts the original values in cells by a small number, either up or down. Well, these two methods actually were used by the UK Statistical Office, ONS, on their census population data sets from 2011, and they are most probably will be recommended to be used for the next European census data collection. As I mentioned before, we don't have yet the results on income statistics regarding the indicators that will be available. But since this combination were used on the, these disclosure methods were used also on Slovene census data, I can show you some results considering this. Here you have population counts on grid cells of 1 square kilometer size and 5 by 5 kilometer size. You can see this is, here you have the presentation of the Selke method, and actually the spatial distribution of absolute differences between cells is shown. As you can see, not many cells were actually the values in cells weren't really that much changed, but I would like to indicate what can happen when this method is used. Well, in this case, we can see that both levels were changed in the same way, while if in the case of the neighboring cell, we can see that on the upper level, the method didn't change the value. The original value stayed the same, so, but on the lower level with 1 square kilometer grids, there were several changes. And by creating this uncertainty in data, you actually lose the additiveness between different territorial levels. So data don't add up anymore. Well, I explained these methods in a very simplified way. So for those who are interested in more details, also on this study, I recommend to find this paper on the web, which was recently released by my colleagues. So let's move now to the last working package, which is aimed to upgrade the current stage 1.0 version. This is how it looks like at the moment. Data are available on interactive thematic maps for 10 territorial levels. So you can look for data on regional level down to 100 meter by 100 meter cell, grid cell size. At the moment, there are around 300 variables available, which are grouped in 20 statistical domains. The application enables user to select different space, content, and time references. It also allows to change class ranges and color scale. Data can be also shared by links and HTML code to embed in other websites. Maps can be also exported as pictures, and geospatial data downloaded as shape files. The application has integrated also a simple delineation tool, which enables users to define areas of their interest and to explore and analyze these units that bring up this area. The content is maintained by the administrative interface, where data are uploaded in shape form files and CSV files, but they can also be automatically uploaded by PX files from our data portal. And in the contents of sharing, it's worth to mention that this application is available to any interested user under the EU public license. Well, so much about the current version. Now the upgraded version will actually provide all the functionalities and features that I mentioned on the previous slide, but there will be some significant differences, especially in the design of the application, since it is developed according to the responsible principle design. And the development also followed the mobile-first approach. So now the application is really redesigned. The these sliders that were in the previous version are now replaced by the friendly touchscreen controls, which are on the desktop version actually a little more adapted. There's also work being done on improving functionalities, considering the map export. And in the delineation tool, there are some, the delineation tool will actually allow the user to interact with map and the chart. I already mentioned that new indicators are planned to be published in the application, and this stage 2.0 application will have a special dedicated site with the stage help section, and this section will actually include not only the manuals for the users, but also some use cases, and it will be the content will be in more educative sense, prepared in more educative sense. This is now my last slide. I only wanted to show you some a simple scheme of the structure of the application. These blue boxes are the components that are developed by the Geodetic Institute, and some of them are compliant within the INSPIRE guidelines. These are the services that allow download, discovery, and view. So that brings me to the end of my presentation. Thank you for listening.
Thank you very much, Monza, for this presentation. Further questions from the audience on this development? No? If none, then, oh, sorry, there. Wait until the microphone arrives there.
Robert, TG Environment. This work?
Yes, it's
okay,
working.
It's working.
Yeah.
Thank you. Very interesting presentation. I've got a very small question. You said it's INSPIRE compliant, made by the Geodetic Office. Is it also available on the INSPIRE catalog? So that you provide metadata on these services, because I think this is a very valuable service for a lot of people, and we can only find them if we know they exist, so if they're documented.
It is published on the National Geo Portal, so I'm not sure about
There's no guarantee that it's published in the European Geo Portal as well, so that well, maybe we should check it out, and then if not, then we'll let you know and ask you to provide some metadata so that everybody can discover these services, because they're very, very nice. Thank you.
Yes, the metadata, discover metadata are being produced by when the request is done. But I'm sorry, I'm not the technician
No problem.
profile,
I think we have to find out as well, because I tried to reach the INSPIRE Geo Portal, but the connection is bad. So otherwise, I could have validated it, but just a question.
Okay. Thank you very much, Yuri. Thank you very much, Mozza. We are going further. Now we're having been south, now we're going up north to the Baltic Sea. And we will hear a presentation about geocoding a business register. Sometimes I'm hearing from my colleagues in INSPIRE, can you please provide us use cases about why and how we can use INSPIRE. Business registers, at least in Eurostat, for example, are used to connect with addresses across the state, and I'm looking forward to the nice presentation from our colleagues here from Statistics Estonia.
Hello everyone, I'm Mari-Liis Otsing from Statistics Estonia, and I'm from Data Warehouse Department, and I make this presentation with my colleague from Dissemination department with Ülle. So, quick overview. I speak a little bit address data systems, and then what we do with Geocoding Statistical Business Register, and Ülle will talk about dissemination. So the address data system was developed on 2008 as a proposal of implementation of Spatial Data Act and Inspired Directive. And it has register status, and it is a framework for the other users and other register. So, and we have this address standard, which consists of structural elements and follows the business rules. So, a nice picture about our address standard, which contains 8 levels of components, and it's more detailed as Inspire request, because we have also these building numbers and even flat or part of the building numbers. So as the Estonia Land Board is the chief processor of this address data system and had developed many ways to the normalization and geocoding tools, and it's very nice to, very convenient to use them, because we don't need to create our own algorithms. So this is, we have X-Road service and this 2 web application. One for mass data geocoding, and even this one single record. And this picture is about mass data coding, when you can choose which output you want to. And now I talk about a little bit how we geocode this Statistical Business Register. We used X-Road normalizer version 2. It is lower than online application, but it is suitable for large data format volumes. So, at first we combined the full list of addresses, and this Statistical Business Register is from 1995, and we got almost 600,000 unique addresses. And they are unstructured and contain zip codes, but currently the zip codes are not in address data systems. And the main problem was also that this normalization and geocoding services working with current state of addresses. They contains historical addresses, but this normalization service doesn't work with them yet. So we loaded the data in the input table, and this normalizer returns the response in huge globe format, and then we decoded it and got this address ID. But to give this value, we need also this address object ID. And we found it with a script. So the goal was geocode the data as best as possible for population and housing. We want to links between buildings or apartments, and also this for business register links to house buildings is fine, but all these non-matched addresses we used cadastral level or settlement levels, and then we mark it as non-geolocated records. So there's the process was round work many times. So we cut off these non-valid levels and tried to geocode it again and again. But the results were quite good. The 72% of addresses were successfully geocoded at first try, and finally it is 86% or more. So what we learned, that the Statistical Business Register contains this parallel address when building had two street names, and so we had to remove the second and so a lot of apartments and the other rooms isn't not yet in address data systems, but they are adding them. And but the good one was that we can easily transform these methods to other register. So for the future, we need to update our address identification because this address data is also involving, and these local authorities are organizing the address data and to process addresses that have not been geocoded yet. So I give my word to Ulle.
I'm going to tell you about the dissemination, the results of geocoding process Mari-Liis talked about. The purpose of geocoding statistical business register data was to give additional value to it through location, to publish this data in a more detailed spatial level, and therefore enable to use this information in spatial analysis. The result of geocoding process was point-based data. The result of geocoding process was point-based data, what allows aggregating statistics to any area. We decided to publish enterprise statistics on grid maps because we use grids also in population statistics, and we thought that it would be important for our users that different small area statistics have same geographical dimension. And also it is important that output is independent from administrative territorial changes. This would make comparing different statistics better and easier to co-use. The big problem when publishing small area statistics is confidentiality. And because of that, they choose to publish the data that don't need disclosure control according official statistics acts, and these are enterprise legal form data, economic activity of enterprises, and the number of employed persons. The selected data was published in Statistics Estonia map application. It is a place where we visualize regional statistics, and it is important that in map application we can publish data about uncommon areas. By that I mean areas other than administrative units. For example, built-up areas and grid maps. Here is a picture of our map application showing the number of enterprises in capital region, and the diagram on the right describes the economic activity of enterprises of a selected grid. In the map application, we use base maps and address search functionality, which are based on Estonian Land Board web services. The data published in map application can be viewed, studied, shared, and downloaded free of charge. And it also has the functionality of spatial queries. This query uses a simple algorithm, find objects inside a specific area and summarize the values. For population statistics, the queries are made on the point-based data, and for enterprise data, the queries are based on grid data. As this functionality needs logging in, it can be done only with an Estonian ID card. And so, in conclusion, the use of address standard in state registers makes geocoding very effective, and therefore we can publish statistics from different administrative databases quite easily, and we can publish the results for small areas. And our map application is a good tool for visualizing statistics and to make spatial queries. Thank you.
Thank you very much, Ulla and Marie-Lise, for this interesting presentation. We have time for one question. None. Then in terms of time, we are rather short. Then I would like to thank you for your presentation again and invite Miroslav to come on stage for the last presentation of this afternoon session. And we will talk about guidelines to publishing statistical data as linked open data. And as I know that our Polish colleagues have already published some of their population distribution data as Inspire services, and now they're proceeding forwards towards linked open data. I'm really looking forward to see what we will hear. Thank you. Miroslav, the floor is yours.
Thank you. My name is Mirosław Migacz. I work for the Central Statistical Office of Poland for almost 9 years now. I'm responsible for all things GIS in the Inspire implementation, and lately I started dabbling a bit into linked open data as well. The name of the presentation is the name of the project that we are running right now, development of guidelines for publishing statistical data as linked open data. A few introductory words about the project. We started in January last year and will conclude in January next year. The project is the part of the Eurostat's Merging Statistics and Geospatial Information grant series. And our main goal is to prepare sort of a background for a linked open data implementation in official statistics. How does the dissemination of statistical data process work right now in our office? We have several different databases. Let's say that we are interested in a certain statistical unit for which we want to acquire some data. All our databases we need to ask with different identifiers. Some of them are numeric, some of them are alphanumeric. And afterwards we get a response which, depending on the database and sort of a distribution channel, we can either view it on a computer, we can view it on a map, or it can be downloaded as a part of a publication. What is our aim? Again, several different data silos we have. We have a territorial unit for which we want to acquire data. We want all data to be accessible via a single identifier that is an internet address. We want all the data to be visible on a computer, and furthermore, for it to be machine readable as well. What are the specific objectives of our project? First, we wanted to identify all statistical units for which we can publish data and harmonize them and prepare geometries for them for respective years. Then we want to build a standardized URIs for those statistical units. Apart from that, we wanted to identify and analyze all data sources that we have so we can see if we can publish them as linked open data. Then we want to prepare a plan of transformation of the existing data sources into open formats. Part of it is a pilot for creating RDF metadata for several data sources. And at the end, we want to conclude the project with a feasibility analysis for publishing linked open data. What are the data sources? We taken into the project 3 major databases that we have. Those are the local data bank. This is the biggest set of statistical information that is available for a large amount of years. It's updated monthly. We also have a demography database, which is a data source for population and vital statistics. And we have a system for monitoring development. It's called Stratec. This is a system that has all sorts of indicators that are in various strategies, either on national, European, or regional level. But we also have other sort of smaller data sources. Those are publications, tables, communiques, announcements, and articles. We done an inventory of all these sources and analyzed them in terms of their openness. So the key aspects were openness, redundancy of information, and popularity. We had a look at view and download statistics of all these sources. All of them were described by metadata, including the thematic category, format, spatial reference, temporal reference, presence of identifiers, which is a key aspect in linking data, and what is the update cycle of these data sources. Another big step in the project was harmonizing statistical units. At the beginning of the project, we took our nomenclature for territorial units for statistical purposes as a basis. This was NUTS regions and local administrative units from NUTS 1 to LAU 2. This is the example of the classification. We had some input data. We had geometries for LAU 2 units. We call them gminas since 2002 until now. We standardized the structure, we standardized the identifiers according to the NTS classification, and then we aggregated the geometries up to NUTS 1. We also have other statistical units that we are taking into account. Those are functional areas, urban areas, and lately an integrated territorial investment areas statistical unit emerge. Those are mostly groups of NTS units. They derive mostly from strategic documents. We created geometries for all these units and will determine how these geometries change in time. So this was the basic idea for URIs for statistical units based on the NTS classification. But just as we thought we had everything figured out, NUTS 2016 entered the scene. And before NUTS 2016, our NUTS 2 level was the same as our administrative level called voivodeships. January 2018 will introduce a division of one of our voivodeships into 2 NUTS 2 regions, so those levels are not compatible anymore. What are the consequences? The NTS classification that we wanted to base our statistical units on was repelled. We are not aware of any administrative changes that will follow the changes in NUTS, so those levels will remain different, the level 2 of NUTS. This causes several problems. It causes problems with INSPIRE services because we based our statistical units and population distribution data on NTS. So we will have to prepare those lovely unuseful GMRs for PD again. We also have our Geo Statistics Portal that serves all sorts of thematic maps based on our data. This is also based on a 5-level statistical unit system. And we thought we had no identifier system ready to be adopted for linked open data until just 2 weeks ago. We created a new classification. It's called KTS. It has been introduced in August 24th. It combines statistical and administrative units again. You see in red the NUTS 2 region that has created the discrepancy. It's right now in the hierarchy, it's below the voivodeship, and it's numbered either 1 or 2 depending on which is the number of the region within a voivodeship. The code has 14 digits. This is an example of this is the breakdown of the code, and you can see an example of how it looked before in the NTS and how it looks after in KTS. I think it's much more feasible, this new code, so NUTS 2016 wasn't all that bad, I guess. But we had to do a bit of work. We had to harmonize our statistical units again. So we have recoded all the units according to the new classification. But apart from that, we also tested some generalization scenarios and chose one to create generalized boundaries for the statistical units. And we prepared both generalized and non-generalized data sets since 2002 till 2016 as one of the results. What do we have left? Actually, what have you seen so far is mostly organizational and inventory work. The most exciting part we have just started, actually. It's the pilot transformation of 3 major databases into linked open data. From the 3 databases I told you about before, we have chosen an excerpt with basic demographic classification. And we are right now designing ontologies for those excerpts from these 3 databases. We are using mainly Dublin Core and SCOS, but in further works we will explore other possible vocabularies that also exist. We also are setting up a software environment for RDF creation. Those include software like OnTop, Apache, Fuseki, and Puppy. And basically, it's a nice exercise because we notice that not all our databases have the same classifications. The classifications are not harmonized in terms of their, for example, age group years, but also they are not always harmonized semantically. So actually, what we need to do first is to link our data within our office, and then we can think about linking them outside. What other activities we have in store? We also want to transform our geographic data into linked open data. The inventory of data sources that we took, we would like to transform into a linked open data catalog. So we want to include it in our search services. And we are also working on developing guidelines for a statistical linked open data web application. Last year in Poland, there was a data opening strategy introduced. It's aimed at opening government administration data with respect to the 5 stars of linked open data. Our project results are and will be very much in line with the strategy, so we really hope that we will be able to acquire financing for a full-on linked open data implementation, which is planned as part of new developments in our Geo Statistics Portal. And last but not least, some of you may know that I am the facilitator for the statistical cluster in the Inspire Thematic Clusters platform. As I mentioned at the beginning of the session, during questions, right after this session, actually in 4 minutes, at the Inspire booth, we will meet for a cluster meeting. So if anyone is interested in talking about Inspire implementation, raising some issues, challenges, or sharing their experiences, with concentration mostly, I think, on the population distribution team we talked so much about today. I invite you to the Inspire booth after the session, and if you can't make it right after the session, we will probably be in the Berlin room. Okay, so that's all from me. Thank you very much.
Thank you very much, Miroslav, for this nice presentation. If you allow me, I would like to wrap up in a couple of. We have 3 minutes left. Super. I mean, we are excellent. I would like to wrap up our session today. What do we have heard in the last 1.5 hours? Peter has shown us the current pitfalls. I would summarize it and further suggested the way further. For example, about SDMX usage, and I'm looking forward to see that suggestion further discussed with the cluster, with my colleagues from DG Environment, that maybe something actually changes on that one. And for me, the most astonishing message I take home from this presentation is that the update process actually in the National Mapping Agency is 1 time a year, and in the NSI is 4 times a year. This was the most interesting fact I learned today. Thank you very much, Pier Giorgio from BKG and your colleague from, sorry, I forgot the name, from Portugal. We heard quite comprehensive overarching presentation on SDGs, what is UN-GGIM Europe doing with it, with best practices, links between communities. For me, the most puzzling question I have myself is now, as Pier Giorgio mentioned, understanding what is an indicator about, at which level. This is a quite puzzling question for me, which I'm coming out of that session today. From Mozza, we heard about the update of the stage application. Quite impressive with the 300 variables within the 2 different statistical domains. What is a little bit worrying to me, or maybe interesting to work on in the future, is that in the confidentiality rules, if I understood you correctly, the numbers don't add completely. Well, there's something interesting to look into that one and to work on. But I mean, really, congratulations. Oh, now the 15 minutes of this is for me. That's for Miroslav. It's not for me. Yeah? Sorry. I apologize for that one. Yes. And. Yes, thank you for this nice presentation. Afterwards, we heard a presentation from Statistics Estonia, from Marie-Lise and Ulla. For me, this is an example of a super collaboration between a national mapping agency and a statistical agency. I mean, processing 560,000 plus records, and I want to cite our colleague from Statistics Croatia, Branko. We are statisticians, we have to be precise, so I apologize that I did not note down the exact number, if it was 560,321 or whatever, so it's just something like 560,000 records. So really congratulations to that one. And what I take home out of that presentation again, we need history. Also in Inspire, we need history, because here in business records, we have maybe some road names which have expired. And we need to somehow geocode that as well and keep it as a record in our others database. Last but not least, we heard from Statistics Poland on the implementation of guidelines of linked open data about the inventory and organizational work. I want to phrase it as a live offer harmonizer and standardizer in Statistics Poland, and the excitement I hear out of his voice about how he looks forward to really create a useful population distribution GML again. Yes, I take home as well, again, a data quality statement from him that he said, in our internal databases, not all classes are always harmonized. And this applies not only to statistical offices, but also to our national mapping agencies. We heard yesterday, I think, 2 or 3 presentations where they talked about edge matching. So I think this is typical things we need to do our housekeeping, our quality assessment, quality control before we can go further. Before I leave you, and I apologize that we are taking slightly longer, for the next couple of conferences, we would like to invite you to a joint UN-GGIM workshop on integrating geospatial and statistical standards, scheduled for November 6 to 8 in Stockholm. Maybe you see this nice sundown in Stockholm on that day. If not in November? Okay, well. No, it's not the best time of the year. Maybe, I don't know, I don't want to be insulting our Swedish colleagues here. I mean, Stockholm is a really nice city. So you have 4 sessions and you can still apply for attending that session if you're interested in more standards-based work. And for the next conference, I would like now to invite the president of the EFGS, Janusz, from our Statistics Poland office, to invite you to the next conference. And for me,
thank you very much. It is a very short announcement. It is a big pleasure for me as the president of European Forum for Geography and Statistics to kindly invite you to our next conference in Dublin, also in November, from 2nd to 3rd of November. And it will be a 10th conference. It is anniversary, and a year ago it was in Paris. 2 years ago it was in Vienna. So this year it will be in Dublin, in Dublin Castle. I think it will be very interesting for people from not only from statistics but also from mapping agency, from academy, because we focus wider on standards, and we try to discuss some metric concerning link open data, Inspire, big data, especially in environmental geostatistics, like Copernicus, and collaboration between mapping agencies and statistics. So I invite you very warmly, because we also I can announce this, that we will have a very important keynote speaker like Jack Dangermond from ESRI and Greg Scott from UN Global Geospatial Information Management Committee, and Mick Corey for Eurogeographics. So I think it could be interesting for you. Thank you very much.
Thank you very much, Janusz. With that one, I'm closing the session, and enjoy the coffee. Thank you.
The cluster meeting.
The cluster meeting, yes. Please stay for the cluster meeting. Thank you very much. Thank you. Thank you for. I will come.
Janusz?